Let us look at Taylor series for f of x equal to 1 by 1 plus x square centered at 0. So again, what is the first step? To figure out the derivatives, successive derivatives. So f0 of x, that is first zeroth derivative of x is equal to the function itself 1 by 1 plus x square. The first derivative of f of x is minus 2x by 1 plus x square the whole square. Now, how did we arrive at this? Now, to be able to do this, you have to remember this quotient too. So, if f of x equal to u by v, then f prime of x, that is the derivative of f of x, is equal to the derivative of u times v minus u times the derivative of v divided by v square. This is called the quotient rule, which is what I have applied here. Okay. Now we take the next derivative. We get 6x square minus 2 by x to the power of 6 plus 3x to the power of 4 plus 3x square plus 1. Third derivative of f of x is minus 24x cube plus 24x by x to the power of 8 plus 4x to the power of 6 plus 6x to the power of 4 plus 4x square plus 1. The fourth derivative, that is f4 of x is equal to this expression. The rule remains the same, so you have to do it carefully. What we have to do is, since it is supposed to be centered at 0, we have to take the 0th derivative at 0, which is 1. So if you make x equal to 0, 1 by 1, 1. First derivative at 0. So x becomes 0, means that numerator becomes 0, which means the first derivative at 0 is 0. The second derivative at 0. Here if you notice, all these will become 0. You'll be left with minus 2 by 1, which is minus 2. Similarly, third derivative at 0. Here, numerator becomes 0. So which means the third derivative is 0. What about the fourth derivative at 0? It is equal to, all these will become 0. 24 by 1 we will have. So 24. Now, if you notice here that f1 of 0 is 0, f3 of 0 is 0. So which means our general term will be f2n of 0 is equal to minus 1 to the power of n times 2n factorial. So it is not n factorial, it is twice the n factorial. And we know the general formula for Taylor series. Now when we apply this formula to this particular context, we get 1 by 1 plus x square is equal to sum as n goes to from 0 to infinity of minus 1 to the power of n times 2n factorial divided by 2n factorial. Now the denominator is becoming 2n factorial because we are skipping the alternate terms. Okay, so this becomes summation as n equal to 0 to infinity of minus 1 to the power of n times x to the power of 2n. Here 2n factorial cancel out. Now when we expand it, we get this. 1 by 1 plus x square is equal to, let's take a few terms. When n equal to 0, this becomes 1. When n is 0, it becomes x to the power of 0. So that is also 1. So 1 times 1 is 1. Now let's take n equal to 1. So minus 1 to the power of 1 is minus 1 times x to the power of 2 times 1. That is x square minus x square. Now let's take 2 minus 1 square will become plus 1 times x to the power of 2 times 2. That is x to the power of 4 plus x to the power of 4. and so on. So this is the Taylor expansion for 1 by 1 plus x square centered at 0. Now here one thing that we have to remember is that the denominator cannot be 0. Now you might say anyhow it is 1 plus something. So even if x is 0, the denominator will never become 0. But just see what happens. When we say the denominator cannot be 0, it means 1 plus x square is not equal to 0, which implies x square is not equal to minus 1, which implies x is not equal to plus or minus 1i. So there is a singularity in the complex plane, even though on the real plane, on the xy plane, there may not be any singularities, but in the complex plane, there is. And since it is there, it means that this Taylor series will not converge to the function throughout. So that means there is going to be a restricted radius of convergence. So let's see what it is. Since 1 plus x square cannot be 0, there is a singularity at x equal to plus or minus I in the complex plane. So radius of convergence is 1. So interval of convergence is minus 1 to 1. Now we can also use a ratio test to figure out this. So let's see by ratio test. Remember, we take only the an part. X part we ignore. So an is equal to minus 1 to the power of n. An plus 1 is equal to minus 1 to the power of n plus 1. Divide an plus 1 by an is equal to minus 1 to the power of n plus 1 by minus 1 to the power of n, which gives us minus 1 to the power of n plus 1 minus n, which gives us minus 1. And now we take it to the limit. We take the limit as n goes to infinity of absolute value of minus 1 to the power of n plus 1 by minus 1 to the power of n is equal to, so basically the absolute value of this, that is 1. So again, radius of convergence through this method is also 1. And interval of convergence will be 0 because it is centered at 0, 0 minus 1 and 0 plus 1, that is minus 1 comma. Now let's look at the graph, how it will look like. So this is the graph for 1 by 1 plus x square Taylor expansion. If we just take the first term of this 1, so this is the graph for 1, only the first term. Now if we take 2 terms, 3 terms, 4 terms, 5 times, 4, 5, 6, 7 terms, you will notice beyond this it doesn't work. It diverges from the function. So only between minus 1 and 1 will it converge. That is Taylor series for f of x equal to 1 by 1 plus x square centered at 0. But if we change the centering, naturally, accordingly, the Taylor series will cover a bigger range, will have a bigger radius of convergence. So this is centered at 3, this is centered at 5. And finally, it is centered at minus 5. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now.